Discuss regarding half-wave control converter with RL load using SCR or Thyristor.
Let us start understanding the working of half-wave converter with R and L load. We are going to give AC signal to this circuit. So that's what we see here. But we are very clear about the point that this SCR can work only for one half of the cycle, and it is going to be switched off for the next half of the cycle. So that's why we are giving a symbol like this for understanding. Now, once the signal is given, the SCR will not conduct immediately. The reason is pretty simple, because we are not providing any gating signal. Unless we provide the gating signal, the SCR is going to behave like an open circuit. Once it is open circuit, there is no chance for any current to flow through. Now, once we give the gating signal to this at an firing angle, let me say alpha, that's the angle at which we give the gating pulse to the SCR starts to conduct. It behaves like a short circuit from now on. Once it starts to behave like a short circuit, there will be good current flow like this, right? So once the current flow starts here, the voltage drop across the SCR is considered to be 0. For an ideal SCR under conduction stage, the voltage drop is going to be 0, because we are very clear about the point that voltage drop across short circuit is always 0. Now next one, let us see in phase wise the working of this one. Right, let me take this as the first phase or first region, this I'll take it as a second region, this I'll take it as a third region, and this one I'll take it as the fourth region, and a fifth region, right? So I'm going to explain you this way. So let me rub this all, and then let me start the explanation now. First, let us talk about the region 1. This region let us talk about. First, we are going to give the gating pulse to this. We are giving the gating pulse here, right? Till that point, the SCR is off. If the SCR is off, the supply voltage, whatever we give, cannot be seen at the output side. So this is the gating signal. It has got nothing to do here. Now this is the V out. So since there is no current flowing till the gating pulse is given, so there's going to be 0 volts, and there is no going to be current here, so that's also 0 current. But whatever the voltage you gave, that will be present across this one. So this is the condition 1 before giving the firing pulse. Now let us see the second region. In the second region, we are going to give this region I'm going to talk about from here to here. Let me draw it more legibly. So this is the region that we are going to talk about. Right here, the circuit represents for this condition. So since the circuit is conducting, the current will start to flow through this. Once the current starts to flow through this, so the current will be flowing through the resistor R, and it will create some voltage drop, and the same will flow through the inductor, and it will create a voltage drop. So the output voltage V out is going to be VL plus VR. Now what is VR? VR is like R times I. That's what is this region. And then next one is VL. VL is like L times di by dt. So this is what is happening. Now let us see this one. So we are given here. So the voltage immediately after giving the pulse, so immediately this output voltage is following the input voltage. The output voltage is following the input voltage up to this point, right? Similarly, if we see here, till this point the current was 0. The current cannot immediately shoot up because we have the inductor over here, so this will not allow it to rise, so it will slowly increase and it will go to the maximum, right? And once it starts to conduct, the voltage drop across the thyristor is going to be 0, because the voltage drop across any short circuit is going to be 0. Clear about this one? Now let us go to the third region. Let me rub this, and let's go to the third region. This is pretty interesting here. Let us understand this region. It's a small region but very interesting. Now what happens here? See, already the inductor has gone to maximum, right? The inductor current has gone to the maximum. Here the input voltage also has started to go into the negative phase, right? And then the inductor starts to reduce or release its current through the I out. Now let us see this. What is VL? Now VL, if I see here, it is like L times di by dt. Now here if I see, the current was initially, let me say here it was some 10 milliamperes or so. It started to reduce to 0. So this is negative. So you will get minus di by dt. Now if I substitute minus di by dt in this region, so it is going to be minus VL. So if it is going to be minus VL, and if it is what is going to be reflected at the output, so we will be shown this way. It will be shown this way in the negative axis. Now let us see this very clearly. It is a straight ramp of negative slope, right? It is not following the input voltage. It is not following the input voltage. So this is due to the effect of the inductor. This is due to the defect of the inductor. Now since inductor is pumping in some current, till that point the Vt is considered to be operating, and hence till this point the voltage drop across the SCR or the thyristor is still 0. Clear about this point? Now we are going to enter into this region of operation. Now during this region of operation, the current has already gone down to 0. The supply voltage has already gone to the negative cycle, so obviously it has to be like this. See this, the negative region that I am indicating, I have shown you here. Now this circuit automatically becomes like open circuit. From this region onwards, it is going to be like acting like an open circuit. So no current can flow through this, and hence since no current is flowing through this, the output voltage is going to be 0 till the gating signal is provided. The output current is going to be 0 till the gating is provided, and the voltage across the SCR is going to follow the input because it has become open circuited. And once it becomes open circuited, whatever the voltage, supply voltage we give, that will be present across the thyristor. Now from here on, it's going to be, now next stage is this region. So here on, if you see, it's a copy paste of whatever has happened over here. So there's no more explanation required. Hope you understood this. Thank you.